back about 11, 12-ish years now to 2007, and I was one of the first employees of a then brand new startup called Delver, and we were tasked with building a search engine. Our product at that company was a full-blown search engine with one unusual aspect to it, which was this was the first what's nowadays called socially connected search engine. So nowadays, if you're searching for stuff with Google or any of the other search providers, and they have some idea of who you are and who your friends are through Google Plus or Facebook or any one of these things, you expect your search results to be personalized based on your social graph. This nowadays is kind of a given. You don't even notice it. Some of you might not even realize it, but your search results are, to one degree or another, manipulated so that your results that have some relation to you on your social graph show up higher than others. This was a very new concept back in 2007, and that was the product that we ended up building. So, given a search engine, what's expected of a search engine, right? What is a good search engine? Well, really it falls around these three primary kind of requirements. The first requirement is it needs to perform well. Who here remembers the pre-Google days? Lycos, AltaVista, etc. Please keep your hand up if you're happy with the results and the performance of those pre-Google search engines. I sincerely hope you're joking, sir, but if not, then... Oh, well, okay, you had no expectations of the world then. Yeah, okay, well, there you go. So people nowadays expect their search engines to perform well. And by well, I mean, let's say sub-second or second-ish, right? If you went back to, say, 2001 or the year 2000, and you typed in a query on AltaVista, and you waited for 8 to 15 seconds just to not get the results you need, Google basically changed that. So we have a lot to be thankful for to Google. So performance is one consideration. Other considerations include reliability. So you expect that if you type in a query and you hit search, you actually get results in. You don't get an error page. And finally, you expect results to be useful because it's a search engine. If it doesn't give you useful results, you're not going to continue using it. So we set up a team. We hired a bunch of engineers and product managers and QA people and so on and so forth. And we used the good old-fashioned software engineering methodology that nowadays we all call TDD. Back in 2007, this was not nearly as prevalent or as well known as it is today. That being said, we still had test specs. We built, we spec'd out the product. We built the tests to match the product specification. We coded the product. We deployed it to production, and we iterated, right? Classic TDD-ish kind of thing. And it was pretty great, right? This was a good experience writing software. It was pretty novel to me back in 2007, but we did end up with a system that was quite reliable. We had we caught some bugs ahead of time before moving to production. We had fast iteration cycles, and probably most importantly, we had a built-in regression suite. So as we were iterating on the software, we had some degree of confidence that we did not break existing functionality. All well and good. So we coded the engine. We ended up with a product that you can actually see a screenshot of here. It took us about a year to actually move from conception to our first iteration in production, and it kind of worked. It was highly available. It did not break very often. Like we did not give our users error pages. We actually gave them search results. It did respond with an SLA, so it was pretty quick, but the results were crap. Right? Fundamentally, you don't want people asking your search engine questions and being unhappy with the answers. This is not a good user experience. People will not pay you. So, if you take all of that together, there's one takeaway, which is green tests are not everything. Like if you have an acceptance test suite, whether you built a test first or test last or whatever, you have a good suite of tests that prove that your product works as specified, that might still not be enough. There is a whole, well, actually more than one. There is a set of categories of software that you might end up building where green tests just don't mean anything. Some examples. Anything that's qualitative or subjective. So search engines is one example. Like one person might look at a set of search results and be very, very happy with them. Another person might mean a slightly different thing and be entirely unhappy with the results. Other examples include things like social feeds. So the way this works is with Facebook, for instance. If you if you go to Facebook, you get your news feed. The way this is constructed is it is designed to make you engage with the platform. Right? For Facebook, the money comes from showing you ads. These ads, uh, these ads only matter if you spend enough time on the platform to actually see more and more of them. That's success for Facebook. They want to show you as many ads as possible and get as much money as possible. So the way they construct the news feed is in a way that makes you, as the user, spend as much time as humanly possible engaging with the platform. Other categories of software where acceptance tests just don't apply, and I might be jumping ahead of myself. Is it clear why acceptance testing or like unit testing, integration testing, any kind of testing that you specify in code are not sufficient to say whether a particular implementation of a newsfeed is good or not? Like, does everyone get why this is not enough? Raise your hand if you don't. Okay. Cool. Seems to be a pretty obvious thing. Other categories include software problems that have huge input space. So machine vision is a classic example. This is a screenshot from Hot Dog or Not, which is this amazing application that classifies an image and tells you whether or not the image is one of a hot dog. This is a joke app that was built by the creators of the TV show Silicon Valley. Silicon Valley is, as someone else once said, an amazing documentary about life in Silicon Valley. I highly recommend it, except I've never watched it, so I don't really know. But this example showcases if you can't, if you're too far away or anything, there's a dog, and it's in a hot dog costume. Now, why anyone would do that is anybody's guess, but the software identified this as an actual hot dog, right? Why? Well, because you can't test the whole input space. Right? If you take even a very old, like 8 megapixel camera sensor, you just cannot enumerate all of the different possibilities. I mean, you can enumerate the possibilities, you can generate any possible image and feed it into the engine, but you can't write tests for that because there's just so many options. We're talking billions, trillions, whatever of options. You cannot generate that many test cases. So obviously, you cannot test the whole input space. Lastly, you have things like resource-constrained problems, optimization problems, things like Uber and Lyft, right? What is a good experience for Lyft, for a Lyft user? Well, you might ask, what Lyft user? Are we talking about the driver, or are we talking about the people actually requesting trips from one place to the other, right? So sure, you might have very obvious success criteria, like you might say that a good experience is someone calling in an Uber or Lyft, whatever, getting a driver come in, pick them up, and drop them off where they needed to. But there's so much beyond that. You have questions of availability of drivers. You have optimization problems where you don't want to just pick the first available driver. You want to pick a driver that's nearby, or where you can optimize the route so that they'd have someone to pick up after dropping you off as the user. Sorry. So resource-constrained problems are ones where also you cannot clearly articulate acceptance criteria, and you certainly can't do it in a way where you can just write a bunch of tests, get a green marker on your build, and be confident that the system is working as advertised. So the first takeaway is that for certain classes of software, and actually more and more of them, like a lot of the software we build today, the definition for what is correct behavior and what is a good outcome are very, very different, or actually orthogonal. Those are two dimensions that you need to take into account for your system, right? If for instance, Google would give you amazing search results, but would break half the time, you wouldn't use it. On the other hand, if Google gave you sub-second results every single time, but the results were horrible, you wouldn't be using it either. So you need to get both right. Correct and good are not the same thing. So if you want to start tackling this issue for any software project, any product of any scale, any consideration, you always have to ask, what does success look like? Okay, in this example, this is a small piece of originally a Japanese game show called Brain Wall. You might have run into this. Basically, you have to contort yourself into a particular shape as a wall moves towards you, and if you've contorted yourself to the right shape, then you remain standing and it's all good. If not, then the wall knocks you over into a pool of water. So, what is the success criteria for someone playing Brain Wall? Well, in this case, it's pretty easy. You don't get wet. If you're not wet, you have succeeded. Good user experience, right? But for any type of project, you have to be able to answer this question. What does success look like for my user? And oftentimes, you would actually have more than one categorization of user, and you have to ask yourself that question for any category of user. Right? For Uber, you have two kinds of users. You have the drivers, you have the people actually ordering ordering the taxi or the Uber or whatever. Once you've asked yourself this question and you've answered this question, the second thing you need to take into account is how do you measure it? Once again, for Brain Wall, it's trivial. You got wet, no success. It's binary, right? You either got wet or you didn't. For a lot of products, it's not quite that clear cut, but you still have to ask that question and you still have to have an answer for it. Otherwise, you just don't know if you're doing a good job or not. Now, I don't actually know this for a fact, but I'm assuming that most people here are software engineers. Is there anyone here who's not a software engineer, by the way? No? Awesome, then it's easy. Engineering is all about making the right trade-offs. In order to make the right trade-offs, you need the right kind of data. In order to get at the right kind of data, you need to ask the right kind of questions. But more importantly, intuition that we all have does not replace data. Okay, so one example is where in a previous company, I was part of a team that, we built a product. Part of that product was a recommendation engine, right? And we spec'd it out like a very minimal version of it, and everyone was on board knowing that the first iteration is gonna suck, right? There's no question that if you're building a search engine or a recommendation engine or a machine learning model or any one of these things, your first iteration is not gonna be great. That's fine. Everyone was on board with that. The problem started in the second iteration, where we had a bunch of people, engineers, QA, product managers, etc. We tried some stuff out, like we built a second iteration of the software. We let everyone play with it for a few days, and everyone came back saying, yep, this looks good, ship it. And we relied on intuition. Like we relied on 10 different people telling us that the product looks better. Based on what? Subjective experiences. That's just not good enough. The end result, by the way, was that once we actually measured our success, and our primary criterion for success was user conversion in that case, it turns out the user conversion had dropped by half. Not 0.5% or 0.5 point. It literally dropped by half, which means users were half as happy with us as they were in the first iteration, despite 10 experienced professionals claiming that the end result was better. Right? So intuition doesn't count. And QA cannot save your butt. A lot of the times what happens with these types of projects is, especially the product management and the project management, they all assume that if you just put enough effort into quality assurance, if you put enough experienced QA people on the problem, they're going to be able to give you a proxy metric for how good you're doing. That's bogus. Right? We had those QA people on that particular project. It did not work. So intuition isn't good enough, and QA will not save your butt. So, what are you going to do? Like, what should you measure? What criteria should you pick? Right? Well, as the case may be, you have customers. Presumably, you have customers. You have people actually interacting with your system. Whether or not that is a good thing depends on whether you're an engineer, a support personnel, or an account manager. Irrespective of how much you love your customers, you have them. And your customers have interactions with your system that you can analyze, that you can record and measure and analyze and figure out. So you can ask yourself two very important questions. What do your users actually want from the system, and what influences that outcome? So if we take a search engine into account, which is the story you started off at, what is the user behavior? Well, the user comes into the system. First, they type in some sort of query. Then, if you imagine what you do when you type a query into Google, typically you kind of skim the first page of results. You read through it very, very, very quickly, and you don't really pay attention to that much detail because your first read through it gives you a good enough idea of whether or not the search results are interesting to you. Once you've skimmed the results, you decide what to do about it, and you might have one of three decisions. You might page forward, like the first set of results is not good enough. You might be interested in more results for the same query, so you move to the next page and the next page and so on and so forth. You might refine your query, which is to say you might take your search query, add a word or adjust a word so that you get better results. And then ideally, if your search engine is good enough, you might actually choose to follow one of the links shown, one of the search results shown to you. Now, crucially, all of these things are things that are outside of your system and outside of your control, right? It's your users that end up making that determination, making that decision. So the second takeaway is that your users are a part of your system. Your users are actors within your software system, within your architecture, and they make decisions that are outside of your control, and those decisions affect the outcome or the viability of your system. So let's ground this a little bit, right? What can you actually do? So with this sort of system, for a search engine, you actually have three very distinct signals just based off of this graph of what your users do with the system. Your users might page, that's a signal. Your users might refine their query, or they might follow a link. Those are also signals. So you can actually measure these. You can, for instance, if a user pages to the next set of results, that's a signal that tells you that you're on the right path. Your search engine is producing roughly the right set of results, but they're not good enough, right? Your users are interested in more results. This gives you the signal that you're on the right path, but maybe you want to adjust the way your search engine works so that it surfaces better search results. Right? Ideally, you want to minimize paging because every time a user has to page, there's an opportunity there for lost revenue because your users might decide, this isn't good enough, I'm out of here. A second signal is refinement. If a user types in an adjusted query as part of the same session, that is a signal that your search results might be fine, but the user realized that this is not what they had intended, and they refine their query. They might want to add a word to disambiguate some search results. The third signal is click-through, and that is your success signal, right? If a user clicked a search result, that is a good thing. That means you have done your job correctly, and your user is happy with one of the search results. Now, this signal isn't binary either. You might want to keep track of what is the rank of the result that was clicked? Was it the first result, the second result, the seventh result? Right, that matters as well because it gives you the opportunity to learn how happy your users are and improve over time. And there's also a fourth signal that's in none of these, right? And that's your user looks at the screen and goes, this is not interesting to me at all, and just closes the tab, right? This is also a signal. This is the signal of failure, but it is a signal you want to track because it tells you whether or not you're doing your job. Now, does this look familiar to anyone? This whole arrangement of signals and tracking them. Raise your hand if you've had this conversation sometime. Right? Okay, that's about a third, maybe a quarter of the audience. The rest of you, I don't know if you should be ashamed or not, but this should definitely be familiar to you because we've been having this conversation for years and years with our product managers and our business analysts. We just call it BI. Or business intelligence, right? We've been having this conversation. We generally have it with product management that are interested in knowing what users are doing in the system. We're having it with business analysts who want to measure whether or not the system works, right? So we have this cycle, normal cycle of software engineering that starts with a product manager determining a change, right? You have a change request in your product coming in from product management. Then that gets fed into you, the engineers in R&D, you produce some piece of software, you deploy it, then it gets measured, the measurements get analyzed, that gets fed back into product management, and so on and so forth. And we have the circle of software life. Now, interestingly enough, measuring and analyzing changes in software and deciding on further changes, all of these things tend to be informed by BI. For some reason, we as software engineers either are totally disinterested or think we're, I don't know, above talking about the success criteria, the success metrics for our system. Generally speaking, our work is not informed by the way our users actually interact with the system. And that's a real shame, because that means that we, some categories of software, we don't really know how to build. We don't really know how to run correctly. We don't know how to improve on them. That sucks. So what can we learn from BI? BI generally revolves around these three things: analysis, experimentation, and iteration. In the case of analysis, really all you have to do is two things. You have to be mindful of your users. You have to know who your users are. And it doesn't matter whether you're developing a search engine or a line of business software or even a library with an API to be consumed by other developers. You always have users. And if you keep that in mind, if you keep your users in mind, if you try to ascertain what it is your users actually want, then you can start having discussions with your business analysts. And your business analysts might be, depending on the size of the company, it might not be a formalized role. It might just be your product management team or anyone else. It doesn't matter. You can have that discussion and try to figure out what your users want, how to measure it. Once you have that, once you have a set of measurements in place, you can start experimenting with your software. You can, for instance, run A/B tests, right? This is bread and butter for a lot of us nowadays, but it all stems from this one realization that the only way to improve your system over time is to measure the success that your users are having with the system and experiment on it. Once you've established a baseline, you can actually prove your improvements, right? If you run an A/B test on your system for anything, it doesn't matter what your system does, you can actually reason about whether any particular change in your system is an improvement or actually degrades its performance. And once you've run experimentation, then you can iterate. You have established your success baseline. You can start charting these things. You can start charting your success metrics, your success criteria. You can start measuring your system by them. You can start alerting on them, right? This is a very, very powerful concept. And it ties into a third takeaway that I'm going to have to explain a little bit, that systems are not snapshots. Or another way of saying this is versions for a lot of systems are meaningless, right? The quality of your system is not a function of the version. It's not a static attribute of a particular build. It's what your system is doing live in production now. It's what your users are doing based on your live system right now. You have to measure it continuously. It's not enough to fix a bug and fire off a new build. You have to be able to tell whether or not that bug fix actually manifests in improved user experience on your system. So you have to measure your production systems continuously. Just having a test suite will not tell you whether or not you've improved. Measurement and constant adjustment will. So that was one example, okay? Now, you might be thinking, but I'm not building a search engine, or search engines are complicated, or this is a solved problem that other people have to worry about. But this is not about search engines. This is about software engineering. There's a large category of software in which these types of approaches matter. So with that, let's move on to a second case study that's a completely different product direction from the search engine that we started off with. I want to take you back to 2011, so a few years after that first experiment. I joined a new startup that you will have never heard of called New Brand Analytics. Before you ask, it failed miserably. It doesn't exist anymore, so don't even bother looking for it. But what the system was is what's nowadays come to be known as a social listening platform. So what it does is the users, our users, were operations managers for things like hotels or restaurants, right? Businesses, franchises with multiple branches, etc. What this platform does is it finds user-generated content that is relevant to those businesses. Okay, so one example, let's stick with one example for simplicity. Let's say our customer is McDonald's. McDonald's runs a franchise of lots and lots and lots of what some people would prefer to call restaurants. I don't know if that's a reasonable term for them, but never mind. They run restaurants. So you can derive a lot of insights about how well your business is doing just by looking at what people are writing on the internet, right? In 2011, this was not news anymore, but the way we went about doing it was fairly novel for the time. So we trolled the web, trolled with a W, I think. We went around the web. We tried to find reviews that were applicable to our customers. So for instance, if someone posted, hey, I went to McDonald's in in the Vilnius airport, I don't even know if we have one here. I went to McDonald's there and the food was mediocre and the restroom was terrible, right? That's an operational insight. That is something we can surface to the operations manager, whether for that particular branch or the whole region, right? If there's a regional manager from McDonald's in Lithuania, or for their EMEA regional manager, or whatever. That's an operational insight that matters. So we would look these up, we would find them, and we would analyze them in order to provide operational analytics for these operations managers. So things like the cleanliness for this branch has dropped 3 points in the last 2 weeks. Maybe there's a problem with the new cleaning service, right? That's an operational insight. Now, this is a 3-stage pipeline. So basically the company, from an engineering standpoint, was divided into 3 separate groups. One was in charge of what we call data acquisition. So it's things like getting data from third parties, integrating with TripAdvisor or Yelp or whatever, doing some biz dev in order to get at the data, and that's going to be the focus of our talk, scraping reviews from the web, right? Just going to TripAdvisor URLs, with a piece of software, with a crawler, and just getting the data in. Second step was analysis, that is taking those reviews and breaking them into structured things. Okay, so whereas a tweet might say the McDonald's in Vilnius is horrible, you might want to say customer 3, branch 15, category cleanliness, score -5, right? That's a structured element that you can work with. Once we had those, we could aggregate them and actually be able to showcase dashboards, reports, analytics, et cetera, et cetera. I want to focus on that first part of data acquisition. That's the part my team at that company was focusing on. And specifically, I want to talk about web scraping, which is the piece of software that actually goes to TripAdvisor without any sort of business relationship between us and TripAdvisor, because they didn't give a crap. We were a small startup. Like, TripAdvisor was already huge back then. They wouldn't talk to us, right? So we just built a piece of software that would go to URLs and fetch data from TripAdvisor in a structured manner. But this had to be done at scale, and because our customers were relying on that data for actual decision-making, operational decision-making at their businesses, reliability had to be very, very high. Now, this is a pretty tough problem to solve, because if you want to do scraping at scale, right? If you just want to write a one-off script that goes to a website, downloads the HTML, and extracts a bunch of values, that's trivial. Doing this continually and across millions of URLs becomes an interesting problem. And that happens for 2 reasons. One is our target sites, say TripAdvisor. Like, if you look at TripAdvisor as a product, it doesn't change that much. If you look at TripAdvisor as a bunch of HTML rendered by a stack of servers somewhere that you don't know anything about, it changes very rapidly, right? If you iterate over your software and you deploy multiple times a day, TripAdvisor certainly does that. So our target sites can change at the drop of a hat. And it's not like they'll let us know that this is coming in the pipeline, right? They'll just deploy a new version, and suddenly our entire crawler infrastructure is going to break, because the HTML that they produced yesterday doesn't look anything like the HTML that they produce today. So that is a huge problem. Another problem is sites like TripAdvisor basically sell their data, right? That is what they do. They thrive on having quality data that is theirs and theirs alone. So they don't want us as a third-party company to just come in and grab their data, right? That is losing their competitive advantage. So they actively resist scraping. And there's a whole slew of techniques around this, the most obvious of which is traffic throttling, right? If you've ever built a site and had a third-party robot hammer away at it, and then you just added like IP blacklisting or one of these things, this is just the tip of the iceberg of a very large stack of techniques that these companies employ in order to avoid having their data quote-unquote stolen by third-party companies like quote-unquote us. So what's important here is that both of these are external constraints. You have no control over them. You have no way of knowing when they're going to happen or how they're going to change. And you can't unit test either of these. This is a statement that's been a little bit controversial when I gave this talk the last couple of times. So does anyone here think that this type of problem can actually be unit tested? I would welcome an argument if anyone wants to. Okay, let's take it as a given that you cannot write acceptance tests for either of these two problems, right? You just can't, because you have no control over the external factors that actually cause these problems. So we try to apply the same kind of methodology of how to reason about this, right? How to get out of this mess, how to produce software that actually works, despite the fact that the acceptance criteria for our software were not clear or were a moving target, and we could not express them as a set of acceptance tests. Here's what we did. The first thing we did was ask, once again, the question, what is success? What is the user expectation that we're trying to optimize for? So when users of our system consumed reviews, what is it that they are actually looking for? And we've identified these three attributes. So our users expected our data, the data that we present to them, to be complete. So for instance, they wanted us to give them a full set of reviews, like good coverage of reviews across multiple sites without missing any. We actually had customers that were anal retentive enough that if we had missed one single review on whatever, a TripAdvisor URL that had like 12,000 reviews, we would get a call within a day, right? What happened to that review? Why isn't it showing up? So completeness was a very, very important success criterion for our users. Second is correctness, right? The data we presented to them had to not only be complete, it had to be correct. It had to actually reflect what the sites of origin displayed. So things like the number of helpful votes or information about the authors, all of these things ended up being important to our users. And it had to be timely. Our users actually expected near real-time results. Some of them were more forgiving, others were less forgiving. But we had a few customers, like big customers, where if a review was posted on TripAdvisor and within, say, 15 or 30 minutes did not show up on our platform, we would also get a call. So all of these things were the top-level requirements that our users had. The next thing we did was to ask ourselves, how do we measure this, right? We know what success looks like now. How do we even reason about it? How do we measure it? How do we know if we're being successful or not? It turns out this was a substantially different category of problems than our engineers were used to solving. This is no longer, does your architecture scale or does your algorithm do the right thing? This is significantly more foreign to me as a line of business software engineer. So the first question is, how do we measure completeness? Right? We have a million sites, like a million URLs, TripAdvisor, Yelp, what have you, and we need to be able to ascertain whether or not we have good coverage of the data that's held in those URLs. Now, you have basically two options of doing that. The first option is you do it manually, right? You set up however it is you choose to do that, like you could use Mechanical Turk or whatnot, but you set up a range of humans whose job is to manually go onto these URLs and extract data so that you can compare. Okay, these are the people that have to spot check or validate the fact that your automatic crawling is doing the right thing. This turns out to be stupendously expensive because this is very boring work. And usually when you have very boring work that at least requires a modicum of common sense, what do you do? Well, you hire students and you pay them pittance, but they're happy because they can do stupid work from home and get paid for it. But there are only so many students in the world, they have only so much time, and more importantly, they make mistakes because it's boring. This is dull, repetitive work. Humans are horrible at doing dull, repetitive work. So even if you manage to find these students, within half an hour of starting to work on this, they're going to start making mistakes just because they don't pay attention, because you can't continually pay attention to this sort of work. It's boring, right? And more importantly, this is sampled. Like, this is not the type of thing you can do on a large subset of your data. You can only do it for a very, very, very small percentage of URLs and sites, etc. So this is not really a tenable approach. The other set of approaches, this is just to give you an example, right? This is what is called, what used to be called computers, right? And I'm not talking about the typewriters and the data stuff. I'm talking about those two women there. They're computers, right? Because in the 50s, if you needed someone to actually do calculations or verify math, you needed to get these people to actually sit down and redo all of the work manually to make sure that your calculations are correct. It is dreadfully boring work. Very few people were capable of doing it at any scale or to any length of time, right? So obviously this is stupid. We got what we nowadays call computers to do that work for us. So computers used to mean people, now it means machines. Wonderful. The other option is you do the validation automatically. And this turns out to be a very difficult proposition because how do you automatically verify something that is essentially a robot, right? You have a script that extracts data from a target website. How do you know that it is correct automatically? Well, one option is you mock the target website. That is a very early idea that pretty much everyone first running into these systems has, right? You mock the target website, you just download a snapshot of it, and you serve that, and you make sure that your scraper continues on working. Well, that is completely useless because your target website can change any second, and you're not going to know. So mocking the target website is not a good strategy. What we ended up doing is we basically took a subset of our sites that was still a small percentage, but statistically relevant and way more than we could do with people. We reran the scrapers. Like, we took some data from yesterday or from last week, data that is believed to be good, and we reran our scrapers on a daily basis or an hourly basis on those URLs, and we compared the data. Now, this might seem to be a binary thing, right? If the data you extracted today is the same as the data you extracted last week, then you're probably still okay. Except that that's not going to work because a lot of the data that you're interested in is data that can change, once again, outside of your control. So just to give you one example, if you have a number or a counter that counts helpful votes in a review, and that's a feature pretty much any review website has, that number might have changed since last week. Is that something that should indicate your extractor is broken, your crawler is broken? Probably not. But that is just one example. You have a lot of these for any given data source. So what we ended up doing is we ended up generating a similarity score. We took the result from last week, we took the result from today, we calculated a score of how similar they are. Basically, the closer together they are, the closer to zero that the score was. And we used a bunch of techniques like edit distance and ignoring fields and various other like typical similarity metrics, and we produced a number. Now this is where a lot of engineers struggle, because we as engineers like to understand what numbers mean, right? If we have this many milliseconds response time, we know what it means. If we have these many terabytes, we know what that means. We like to assign concrete, intuitive meaning to the numbers we employ on a daily basis. And this similarity score is just a number. It doesn't mean anything, right? You don't even know whether a result of 1 or 5 is a good result. Maybe 1 is excellent and 5 is horrible. Maybe 5 is just fine and 10,000 is crap. You don't know ahead of time, right? You don't have any intuition about that number. But it doesn't matter because you can start charting those numbers. You can start graphing them. And then you can start applying very, very simple anomaly detection functionality to it. So even the most rudimentary anomaly detection systems, things like what you get with Anodot or Datadog or all of these types of operational systems that give you a very, very, very basic form of anomaly detection, even those were sufficient for us to actually identify anomalies ahead of time. Now, we did have some false positives. That is, these systems indicated a problem where a problem did not exist necessarily, but it meant that we could be notified of a problem with our data extraction long before our customers called us and yelled at us. And that was a very, very, very good thing for us, right? It increased the reliability index of the system, or in other words, it decreased the number of incidents of unhappy customers significantly. But we had to first struggle through, we had to stop having that debate of what do these numbers mean. Is an increase bad or a decrease bad? We had to stop thinking in those terms and start thinking in terms of, we have a number, we can chart it over time, and we can track its behavior over time without any reasoning about what the number actually means. We did basically the same thing for correctness, right? So completeness would be, in order to measure completeness, we had to be able to have a fuzz factor when comparing two results. That turned out to be also very good for correctness testing. So if a site had changed and you stopped being able to extract a few fields, that would also reflect in the similarity score. So that turned out to be a very, very good solution for us. The other problem we had is that, as we said before, the target sites do not want to be scraped. TripAdvisor does not want you to get at their data. And I'm using TripAdvisor as an example because it's one everyone knows, but we had 50 of these. Can you imagine having to get a call from a customer on a daily basis saying one of these 50 is broken and then having to go and fix it, where the fix oftentimes basically meant rewriting your whole script that extracts data from the target website? You don't want to do that under fire. You want to do that at your leisure if possible. So the earlier on you know that you have these problems, the better your life is. These target sites do not want to be scraped. There's a wide variety of techniques that these sites use to prevent you from scraping their data. The two most common ones are IP throttling. So if you have a server somewhere and you're hitting TripAdvisor fairly hard, they're going to notice very quickly that there's an unusually large amount of traffic coming from a single IP address, and they're going to blacklist it, right, or throttle it at any rate. The other technique that's harder to deal with is traffic fingerprinting, which is to say that they look at your requests more holistically, right? You have an HTTP request coming on top of a TCP stream. You can start reasoning about some attributes of that traffic. You can create a fingerprint and you can tell if two requests that are coming in from different IP addresses, how likely is it that they represent the same source of traffic, right? That is a very hand-wavy kind of description. Now, typically, there is one very easy way of solving these problems, and that's called using a third-party proxy, right? You might use VPN providers, you might use the Onion router, you might use third-party HTTP proxies that multiplex your requests among a great many IP addresses, and we did all of these things, and it wasn't good enough, especially with traffic fingerprinting, with the target sites getting more and more sophisticated. This became an issue. And more importantly, these third-party providers are super expensive, right? And it eats away at your, it basically cuts down on your ability to do stuff because your operational expenses go through the roof just getting that traffic out. So we had to start solving for this problem. Now, this brings us to the question of timeliness, right? Basically, if you have IP throttling, but your users don't care about how near real time you actually bring in the data, then you can just, whatever, reduce your traffic to sampling a target URL once a week or once a month. That might be good enough. It certainly is good enough to not be throttled, but it might not be good enough for your users. So we started thinking about this concept of timeliness, this expectation of our users that new reviews show up very, very quickly, a lot more closely. And we ended up figuring out that timeliness for this type of system is an optimization problem, right? Our only way of getting at new reviews is to pull those URLs. We need to, once every now and again, fire off a request at a site and be able to actually say, okay, there's a new review here, right? And that is costly, as explained. Like, if you do that at scale, you're going to get blocked. If you're going to get blocked, you're not going to be able to do polling, and then you're even less timely than before. So the frequency at which you pull a particular URL determines the latency or the resolution in which you find new reviews. And because there's a cost to polling, it turns out that good for this type of system is a trade-off, right? In order to provide timely data to our users, we had to either spend a lot of money or find some other means, find some other way in which we can actually offset that cost. So, and this is the last slide, I promise, or rather the last slide before the wrap up. What we did is we built a cost model, right? It turns out that we could actually look at the cost of bringing a single review as an atomic unit, right? How much does it cost to get a new review from TripAdvisor? You factor into it hardware costs and proxy costs and all of these things and engineering costs, etc., and you have a number, right? This is how many cents or how many dollars it takes us to bring in a review from TripAdvisor. This is one from Yelp. This is one from some other sources. And that was the beginning of a wonderful process because this allowed us to start having tiered SLAs. Not all of our customers were as bothered about the timeliness of data. Some of our customers wanted near real-time performance. Some of our customers didn't mind if a review came in within 24 hours. Some of our customers didn't even mind that. And it was also different per source. So once we were able to start reasoning about these things, having a cost model in place, we could actually start charging our customers that were more interested in more timely reviews much, much more, because it cost us more to make sure that we can provide that service to them. And we also built that into our scheduling, right? We actually had different categories of customers and different categories of service per target site, and we built that into our scheduler so that we can actually have the highest quality service for our customers within a particular budget. And that was remarkably effective right up until the company went in the gutter. But it's not because we ran out of money. It was because we were very badly managed, unfortunately. So, to recap, takeaways. Correct and good might not be the same thing. In fact, the more divergent these two dimensions of your system are, the harder it is to actually figure out how to build your system correctly. Users are a part of your system, right? If your quality of service depends on decisions your user makes, measure them. Make them a first-class, measurable element in your system, something that you chart, that you include metrics of in your dashboards, that you take them into account in your algorithms. And finally, systems are not snapshots. Versions do not matter. The only thing that matters for a production system is how well it behaves right now compared to yesterday and the day before and the week before that. Right? So stop thinking in terms of incremental improvements and start measuring these things continuously, and then you can actually start making sense of how well you're doing and what the next step is in order to improve your quality of service to your customers. And with that, I believe we're out of time for questions, but I will be available for anyone for anything really. Thank you very much for your time and have a great conference. Cheers.